All right, this lesson is on finding derivatives, and we'll start with the basics. So the first rule is the power rule. We want to come up with a derivative without using a definition every time. That is the limit definition, where you have to find the difference quotient and take the limit as h approaches 0. That can be very tedious, so now we're going to learn the shortcuts. The first rule is the power rule. There are 3 parts to this rule. The power rule says if you have a function x to the n, that means a variable x to some numerical number power, then the derivative f prime of x is equal to n, that power, times x to the n minus 1. So you take 1 from the power. Okay? So what it would look like is this. If I have f of x equals x squared, then the derivative is this 2 is going to come to the front, 2 times x to the 2 minus 1, which we'll do in our head, and that's 1. So the derivative of x squared is 2x. There is another rule called the constant rule, and the constant rule says if there's a number in front of the power, front of the function, so a times some f of x. That just means that the constant just comes on down and then you take the derivative. But that's actually a little more confusing than what it is when you actually practice it. So let's look at examples. So if you have a function 3x to the 5th, we know from the power rule that 5 is going to come to the front and multiply, right? But the 3 is already being multiplied. So what you can do is the derivative is 3 times 5, which is 15, times x to the, and then you reduce that power by 1, x to the 4th. Now, when the numbers get a little bit more difficult and I don't feel like going to Excel, Excel's my calculator, sometimes I'll just do this and leave it unsimplified if it's difficult numbers. I'll just use this rule. This 3 comes down, and then the derivative of x to the 5th is 5x to the 4th. And you can see that means the same thing. It's just this isn't multiplied together. So sometimes if it's easy, you just multiply them together. If it's not, you can leave them that way. And in this class, you get to leave it unsimplified. So also from this rule is that the derivative of a constant is 0. So if you have a constant, like f of x equals 5, then the derivative of the constant is 0. So let's see. Here's another example. Back to the power rule. This derivative is going to be the derivative of x to the 4th, 4. You can think of it as 4 times 1 is 4, x to the, reduce that by 1, 4x to the 3. All right, what if you have negative exponents? This is actually the way that you want this to be. I could take it up a notch, and let's say I gave you this problem. You would not want to take the derivative when it's written in this form. What you want to do, you have to remember your negative exponents. So just to remind you, a negative exponent, a to the negative n, is the same as, if you think of it as a to the negative n over 1. This flips, and it becomes 1 over a to the positive n. So if we do this backwards, 1 over a to the n, this a to the n goes to the numerator and becomes a negative. So that's what's happening here. So you might want to rewrite, and that's where we start. So 12 over x to the negative 2 is the same as 12 times, I'm sorry, I said it wrong, 12 over x squared is the same as 12 times x to the negative 2. So that's where we start here. So sometimes you might have to rewrite. All right, so the derivative, you can either multiply it out or you can just use the constant rule. So if you use the constant rule, that's 12 comes on down, and then times the derivative of x to the negative 2 is negative 2 x to the, and if you reduce negative 2 by 1, you actually get negative 3. Negative 24 x to the negative 3 is the derivative. Next rule, the e to the x rule. If a function is e to the x, then the derivative is e to the x. So that's a really easy rule. All right, you can read in the book why that's true. but simply the derivative of e to the x is e to the x. This rule 4 ends up being something that's tricky the whole semester, and it's really because of the rewriting that I just told you about in a few examples ago. This is a natural log function, the natural log of x. The natural log of x. Okay, that is, this function. It looks like this. The derivative of that is 1 over x. This is not a rewrite. This is actually the derivative of it. And so you have to remember that. It's kind of tricky. All right, so if you have g of x equals natural log of x, then its derivative, not the rewrite, is 1 over x. It seems like it totally doesn't relate, but it is true that this is the derivative of that. The next rule is if you have more than one term that you need to take the derivative of. So this is the addition rule or the subtraction rule. And it just means that if you have to take the derivative of a bunch of terms, you just take the derivative of each term one at a time. So what that would look like is this. So if you had the derivative of f of x equals x cubed plus x squared plus 3x minus 5, all of these terms are separated by addition and subtraction. So you can take the derivative of each of these individually. So the derivative would be, the derivative of x cubed is 3x squared, and the derivative of x squared is 2x to the 1, and the derivative of 3x is just 3, okay, because that's x to the 1, so constant comes down, reduce that by 1, and you have x to the 0, which is 1, so the derivative of 3x is just 3, and then the derivative of minus 5 is just 0, so you don't need to write that down. All right, so we have all the rules, all right, so now we'll practice. So this rule has a bunch of terms, so we're going to take the derivative of each one. So 4x cubed, well, that would be 3 times 4 is 12, and then x, and you reduce that by 1, so 12x squared. Then minus 2x to the 4th, we can take that derivative, so negative 2 times 4, that's negative 8x to the 3rd. And then the derivative of minus 5x is minus 5, and then the derivative of minus 2 is 0. Okay, so now we get into some more difficult ones. Example 7, g of x equals 2x to the negative 3 minus 5x to the negative 2 plus 6x to the negative 1. Well, the good news is these are already written in, they're ready for the power rule. They're written in this form. So we just know how to take the derivative of that, whether it's a negative or exponent or not. So you multiply 2 times negative 3, that's negative 6, and then you got to remember to reduce that by 1, which makes that negative 4. Okay, the derivative of negative 5x to the negative 2 is negative 5 times negative 2 is positive 10x to the negative 3. And the derivative of 6x to the negative 1, well, 6 times negative 1 is negative 6, and then x to the negative 2. And you can leave it that way. You don't have to rewrite it. All right, we haven't done this yet. These are called rational exponents. So we'll talk about how to rewrite and get it in this form again. So this is the good form. This is the form we want. A variable to a power. So we're just going to use the power rule, even though we have rational exponents. So the derivative would be 1 times 1/2 is 1/2 x to the, now what you want to do here is you want to subtract 1, right? But you have to subtract from a fraction, so we need a common denominator, so you'll just, the 2 is the denominator, so you can make 1 2 over 2. And then 1/2 minus 2 over 2 is negative 1/2. So that's the derivative of x to the 1/2. Same thing for this one. The derivative of x to the 3/5 is positive 3/5 x to the, and then we need to subtract from 1, right? Well, we need a common denominator, but this time the denominator is 5, so we're going to subtract by 5 over 5. That gives you negative 2/5. All right, and then the last one, minus x to the 7/4, that derivative would be minus 7/4 x to the, and we need to subtract 1, right? We need a fraction, and the denominator is going to be 4, so that would be 4 over 4. So 7/4 minus 4/4 is 3/4. And you're done. Okay, so now example 9, we get into this process where sometimes we need to rewrite the function or any piece. So if it doesn't look like ax to the n, then you're going to need to use negative exponents or rational exponents to get it to look like this. So we don't want division. 1 divided by x to the negative 2, we need to rewrite that, not take the derivative, but rewrite that. And the square root of x, we need to rewrite that, not take the derivative, but rewrite. So I use function notation to remind me what I'm doing, but some students aren't great with their notation, so I teach them to just write an RW, which reminds us that we're not taking the derivative yet. We're just rewriting this function. We're not changing the function, the value of the function. We're giving it to you in a different form. So 1 over x squared is, you can take that x squared and move it to the top using negative exponents. So 1 over x squared is the same as x to the negative 2. All right, now how do you rewrite a radical? Well, there's an index of 2, and this here has an exponent of 1. Okay, so the way you do this, the nth root of x to the n, for any number that's here, not just 2, but any number and any number here, you can rewrite that as x to the n over m. The index always is in the denominator. So the square root of x is x to the 1/2, and that's not anything different. That's just a different way to describe that same piece of the function. So now that it's written in this form, I'm going to take the derivative. So we have a preparation step before we take the derivative. So x to the negative 2 would be negative 2x to the negative 3. And the derivative of x to the 1/2 would be 1/2 x to the negative 1/2. And that's it. Okay, let's continue practicing with some e to the x and natural log of x. So, but these, remember, these are separated by a minus. So these are terms, and you can take the derivative of each of these terms separately. Okay, so the derivative, when you look through it, we don't need to rewrite anything. We just need to remember the different rules. So the derivative of e to the x is e to the x. Now, this is interesting. This is minus 2 times natural log of x. And we have a rule for natural log of x, but what do we do with the 2? Well, the 2 is a constant, so what you can do is you can do it two ways. You can say, all right, the constant comes on down. That's from the constant rule. And then the derivative of natural log of x is 1 over x. Okay, or you could have known that when you multiply 2 over 1 times 1 over x, you get minus 2 over x. Either way. All right, and then the derivative of minus 7x squared is minus 14x. And then the derivative of minus 23 is 0. Okay, I just added one last example and just kind of added some different things that are common errors for students. And so let's do this one. So the first thing you want to do is you want to look and see that they are separated by addition and subtraction. So each of these are terms that we can take the derivative of individually. And then the other thing you want to notice is that some of them don't need a rewrite, but some of them do. And this is a common error for students, especially students who just don't like to write out everything. You're used to doing things in your head. Some students notice that you have to rewrite this and rewrite that, but they kind of, I don't know if they just do it in their head or they only rewrite those, and it gets them confused, and they take the derivative of half of them and then the second derivative of the others or something. So my tip for you is, even if you don't have to rewrite this one, if you have to rewrite anything at all, rewrite them all. Because what you want to do is you never want to be looking at two levels of your problem. So you want to leave this forever and rewrite the whole thing here so you don't have to look in two different places. That's what happens to students. So I know I don't have to rewrite that one, but I do have to rewrite this one. So I'm going to rewrite it. So I made a mistake. So I get rid of this prime here. I'm going to write RW. This is not me taking the derivative. You're not taking the derivative. You are not taking the derivative. See, some people take the derivative here and here, but you're not taking the derivative. You're just rewriting. Okay. But since you didn't have to rewrite here, sometimes people take the derivative. You'll see what I mean when you practice. Okay, now it's time to rewrite. So again, the way you rewrite this, remember x, the nth root of x to the n is equal to x to the n over n. Okay, so this 5 is a constant. 5 times x to the 4 over 3. And then you have to rewrite this one. We're not taking the derivative, we're rewriting. So this 3 comes down, and then you have x to the 5 over 6. And then this one, we need to rewrite this one. This 1 over x is a common error people make. This is not natural log. You got to rewrite this and put it in power form. So when you move that x up in the numerator, that becomes x to the negative 1. And then this is a common error. People always ask me about this, and they're always kind of shy about it, and then yet like 90% of the class doesn't know how to do it. X over 5, okay, x over 5 is 1x over 5. You put the understood 1 there. And then, see that 1x over 5 is the same as 1/5 times x. Such a common question people have. So I threw that in there. All right, so I'm going to rewrite that. That is, we just figured out that's 1/5 times x. Okay, I have not yet taken the derivative. Now I'm going to take the derivative because everything is in power form. The derivative of 7e to the x is 7e to the x. Minus the derivative of 3 times natural log of x is 3 times the derivative of natural log of x is 1 over x, so that's minus 3 over x. All right, here's an example where I don't want to multiply this out in my head. You can if you want. It would be 20 over 3. But I'm going to show you what I do and what is great to be able to do in 263, and that is just write the 5 down. The constant gets to come on down. And then the derivative of x to the 4 thirds is 4 thirds x to the 4 thirds minus 3 thirds is 1 third. And same thing here, plus 3 times the derivative of x to the 5/6 is 5/6 x to the negative 1/6. And now here, remember this one, 1 over x, it's not natural log of x. The derivative of x to the negative 1 is negative 1x to the negative 2. And remember this one, x over 5, the derivative of x over 5, which is minus 1/5 x, is just minus 1/5. So I hope that last example helps you. Okay, so we have just covered first 5 basic rules of taking the derivative. The power rule is very important, and combine it with the constant rule. If you have a power x to the n, that's going to be n times x to the n minus 1. If you have a constant in front, that constant just comes on down. All right. So then you have the e to the x rule. The derivative of e to the x is e to the x. And then you have the natural log rule, which the derivative of the natural log of x is 1 over x. Then this rule says that if you've got a bunch of terms added or subtracted, you can take the derivative of each term individually. So that's your 5 basic rules. Please practice every single problem in the lab manual and in WebAssign, and check the keys.